The Smart School Class 7 Science Video Lesson 3. We are going to study chapter number 1, that is heating and cooling. Our topic today is transfer of heat. We shall be studying from page number 5 to page number 10. During this lesson, you will need your science fact file 2, your textbook, notebook and pencils. Let's start. By the end of this lesson, you should be able to define conduction, convection, and radiation. Explain the three mechanisms of heat transfer. Distinguish good and poor conductors, emitters, and absorbers of heat. And how heat loss is prevented in a vacuum flask. First, we shall do a bit of a recap of what we have studied in the previous lesson. What do you see in this picture? Yes, the ice cream is melting. Why does this ice cream melt? Yes, you are right. It melts due to the transfer of heat from the surroundings. As you can observe, ice cream is colder than its surroundings. So heat from the surroundings comes into the ice cream. That is why ice cream is melting. What is happening in this picture? You can see this droplet getting smaller and smaller until there is no water on the leaf. This is happening due to evaporation. Evaporation is when liquids convert into vapors. Some important words for this lesson are going to be conduction, conductors, insulators, convection, convection currents, radiation, electromagnetic, infrared, emitters, absorbers, vacuum, and thermos. The transfer of heat can take place in three ways. It can take place through conduction, or convection, or radiation. We shall start with conduction. So what is happening in this picture? What do you observe? The hot tea in the cup is raising the temperature of the metal spoon. So that heat is traveling from one end of the spoon to the other end. See, the heat is transferring, and this sort of transfer of heat through a solid is called as conduction. Conduction only happens in solids. This is a bit of a step-by-step introduction towards the process of conduction. If we start heating a metal rod on one end, how will the heat transfer from this end to the other end? In the second step, the particles of the solid will start vibrating, and in doing so, they will be transferring their energy from one end of the rod to the other end. You must remember that the vibration is the only way in which solid particles can move. So these vibrating particles, they will bump into each other. In this way, they will transfer energy from this end to the other end. In the third step, the energy transfer will take place when one end of the rod will be heated and temperature raise will be felt on the opposite end. This transfer of heat happens through conduction. Conductors versus insulators. Why is this person holding this hot metal pan with a cloth? What is he trying to avoid? What will happen if the cloth is not there? Yes, the hand of the person will burn. So that is prevented with the help of this cloth here, because this cloth is not allowing the heat to pass through. The cloth does not let the heat to pass through. Such materials are called as insulators. What do you see in this picture? Water in the pan is being boiled. You can see the disturbance at the water surface, which is an indication of the boiling of water. We shall now try to see the mechanism behind this movement on the surface of water. What happens is that the heat from the stove here warms the water that is close to the stove, and this warm water rises because it is less dense as compared to the cold water that is still at the surface. Now this warm water rises and the cooler water sinks. It comes down towards the stove. Ultimately, this cool water is also warmed by the stove. This continuous process of movement of hot water above and the movement of cold water down is called as convection. How is a room warmed by a heater? The answer is in the process of convection. See, when the heater is turned on, the air around it becomes hot. Hot air is less dense as compared to the cold air. That is why hot air rises up and the cold air, it sinks down. This process continues until all the air inside the room becomes hot. So when the hot air rises up, the cold air replaces it. And when this becomes hot, it rises, and this hot air which has become cold in the meantime, it takes its place. This is a sort of a cycle, a continuous process. That is why we call it convection current. The process of convection is also responsible for the blowing of sea breeze. Here our energy source is the sun. It warms up the land quickly, so the warm air rises from the land. As a result, the cold air from the sea move towards the land. This is called sea breeze. We have just studied that conduction happens through solids and convection takes place between liquid and gases. But there is no such case when we talk about the heat that reaches from the sun to the earth. So how does the heat from the sun reach us? The answer is radiation. Heat waves travel in the form of electromagnetic or infrared waves. These are special sort of waves which do not require any air, gas or a solid to move through. They can move through space, and that is how heat from the sun reaches the earth. We shall now apply our concepts to find the answer of this question, that why is heat in an oven not transferred by either convection or conduction. Convection happens through air or liquid. Obviously the air is present inside this oven, but hot air rises up and the thing that is to be cooked will be placed down. Therefore, convection is not the answer as to how heat is transferred to the food that is to be cooked. Now, to conduction. Yes, there is air inside this oven, but air is not a good conductor of heat. Therefore, there is no heat conducted through air. The only mechanism of heat transfer that is taking place inside this oven is radiation. A quick quiz To assess what we have learned so far, can you tell which heat transfer mechanism is taking place in this picture? Let's try to find out the answer to this question. Radiation is one of the transfer processes taking place. Heat from this stove will transfer without the presence of solid, liquid, or a gas. That is radiation. Conduction is happening when heat from the stove is transferring through the metal pan. That is a solid, and in solids, heat transfer happens through conduction. Convection is when the layers of water go up and down. Warm water goes up and cold water comes down. This continuous process happens due to convection. So the answer is that all three mechanisms of heat transfer are taking place. We shall now see a video that will further explain these mechanisms of heat transfer.
Conduction. If you stir a boiling liquid with a plastic ladle, after a few moments, the ladle will become quite warm. The same will happen with a wooden ladle. And a ladle made of metal can even become too hot to handle. This is because the heat from the boiling liquid is able to travel up the length of the three ladles, quite slowly through plastic and wood, and very fast through metal. But how does heat manage to do this? How does heat travel through things? Well, when the hot liquid heats up the end of each ladle, its molecules, or in the case of metal, its individual atoms, start to vibrate more rapidly. And when the heated molecules, or heated atoms, vibrate faster, they start bumping faster and faster into their slower neighbors, causing them to speed up in turn, and bump into their neighbors, and so on all along the ladle. In this way, the increased speed of vibration, and therefore the heat, is passed on from molecule to molecule, or from atom to atom. Heat is conducted by a sort of domino effect from molecule to molecule, or from atom to atom, along the hot object and into your fingers. That's one kind of heat transfer. Convection. The hot object causes the molecules of air above it to speed up. The hot air expands and becomes less dense, and is therefore conveyed upwards. That's a second kind of heat transfer. You look nice and warm. Where does the heat for that hot water radiator come from? The furnace, of course. Is the furnace always kept in the basement? Why couldn't it be in the attic for a change? What would happen if it were? Anyone on a floor below would freeze. That's what would happen. Why is this? The furnace heats the water in a tank. The hot water rises up through these pipes and into the radiators, where it cools, and then the cold water flows down through these pipes and back into the tank, where it is heated up again, and so on. But why does hot water go up and cold water go down? Because of the principle of buoyancy. If you hold something that is less dense than water, such as a cork, in the middle of a beaker of water, the buoyant force pushing that cork up will be greater than the force of gravity pulling it down. And as soon as you take your hand away, the cork will rise to the surface. Now, when water is heated, its molecules speed up and it expands and becomes less dense. And this less dense water will therefore go up, and then cool and become dense again, and therefore go down. And that's exactly how hot water heating systems work, and why your furnace is in the basement. The principle of buoyancy applies as much to gases as it does to liquids. When air is heated, its molecules speed up, and it expands, and becomes less dense. And so hot air rises, just as hot water rises. Hot air goes up, it cools, and the cold air goes down. Since the behavior of gases and liquids is so similar in this and many other respects, but how can the sun transfer heat to you? You're not touching it, so there can't be any conduction, can there? And since most of the space between you and the sun is just that, space, except for the thin layer of air formed by the Earth's atmosphere, there can't be any convection either, can there? Because once you get beyond our atmosphere, there's almost nothing out there to do the convecting. But the sun still feels hot. Amazing. How is that possible? Is there a third kind of heat transfer which allows heat to move through empty space? Yes, there is. And to understand it, you must first of all remember that heat is a form of energy. Now, energy can travel in various ways, but one of the chief ways in which heat energy travels is in the form of waves. By means of waves, energy can move through any distance. You can do it yourself. You can make that umbrella move without touching it. Tie one end of your rope to the umbrella, and now move your end of the rope up and down. You can actually see that your energy is traveling through the space between you and the umbrella, and then making the umbrella move. The heat energy from the sun travels like that. The sun sends out waves of heat energy in all directions. Each of them is rather like the spoke of a wheel, and this is exactly what scientists call them, only they use the Latin word for spoke, which is radius, from which they get the word radiation, the name given to this third kind of heat transfer. So it's by means of radiation waves that the sun can transfer its heat energy to you and make your molecules go faster and therefore make you hotter, even though the sun is millions of miles away. Just as by means of waves again, you can transfer your energy to the umbrella and make it move, even though you're standing several meters away from it.
Conductors and insulators. Conductors are objects that let heat pass through them, and insulators are the objects that do not let the heat pass through them. You are to identify the following objects as conductors or insulators. The correct arrangement in the categories of conductors and insulators will be like this. Nails, wires, and kettle are all made of metal. That is why they are conductors. Dry wool, paper, and plastic bottle are insulators as they do not let heat pass through them. Radiation is a heat transfer mechanism. In this heat transfer, some surfaces are emitters and some are absorbers. Heat transfers from the emitters towards the absorbers. You are to guess which of these is the best absorbing surface for radiation. Here is a hint for you that a best emitter of heat among these surfaces is this dull black surface. Shiny black surface is still a good emitter, while the worst emitter of heat among these three is the silvery surface. Another thing that you should keep in mind is that good emitters of radiation are also good absorbers. That means the best emitter will also be the best absorber, which is the dull black surface. You may have observed that the drinks inside a vacuum flask remain hot or cold for a long period of time. And that happens because the vacuum flask does not let the heat flow. It prevents the heat flow by three features. Number one is the plastic stopper that is right at the top. The plastic stopper prevents heat loss by convection and conduction. Then there is the vacuum between its walls. The vacuum avoids convection as well as conduction. So the convection and conduction, two of the heat transferring processes, are prevented by the plastic stopper and the vacuum. We only have the third mechanism of heat transfer to worry about, which is radiation, and that is prevented by the silver lining. We have just studied that a silvery surface is a bad emitter and absorber for radiation. So the radiation is reduced with the help of silver lining. That is how a thermos flask or a vacuum flask maintains the temperature of the fluid that is present inside it. A quick quiz based on what we have studied so far. Heat transfers through conduction takes place in solids, gases, or vacuum. The correct answer is solids. The working of a refrigerator is shown in the picture on the right side. All three heat transfer mechanisms are taking place around the refrigerator. You may have noticed the cool air that touches you when you open the door of a refrigerator. You feel cold because the heat transfer is taking place. You need to tell that heat transfer takes place by convection or conduction or radiation. Which of these processes is responsible for that heat transfer? The correct answer is convection. You can see two houses that are painted with different colors in these pictures. This is a house painted with white color and this is a house painted with black color. In which of these houses heat transfer through radiation will be prevented? The answer is through the white painted house, because white surfaces are bad emitters and absorbers of radiation. Therefore, heat transfer will be prevented. We shall now summarize what we have studied so far in this lesson. Heat transfer can take place through conduction, convection, or radiation. Conduction takes place in solids, convection in liquids and gases, while radiation takes place in vacuum. Metals are good conductors, while plastic, wood, dry wool are examples of good insulators. Dull and dark surfaces absorb radiation, and shiny surfaces reflect radiation. Vacuum flask prevents heat transfer. It does not allow conduction, convection, and radiation to take place. For your home task, you have to read pages 5 and 10 of the textbook, and you have to attempt exercise questions 1, 2, and 3 that are given in these pictures as well. Here, question number 1, which is shown as multiple choice questions. Question number 2 is true or false. And in question number 3, you have to use the given words to fill the gaps. You will attempt these questions on the space provided on your textbook. Good luck!